Good morning, everybody. Today, I want to explain the formulas of Laplace transformations, which are very important if you want to complete the problems on this topic. And now, before moving on to a problem, let me explain the important formulas of Laplace transformations, including the definition of that Laplace transformation. Simply, transformation is nothing but transforming a function into another. And here, Laplace transformation. And here, if you able to understand the formulas of Laplace transformations, that means, and here I'm giving without proof. These are the formulas I'm giving without proof. If you want the proof by using this definition, we can prove these answers, how these answers came. And now here, let me explain this definition first. Definition. And throughout this topic, throughout this unit, which is related to Laplace transformations, we are going to find Laplace transformations for a function. For a function, I'm going to take that function as f. And here, every function, and here we are going to consider a function of single variable, and that single variable we are going to take as t. And here we are taking for uniformity, we are taking that one as t, but you can take x or y or any variable you can take. And here generally we will take throughout this unit f of t, that means a term which is in terms of t. For that term which we are taking as f of t, we are going to find Laplace transformation. And here Laplace transformation of the function f of t is, the definition is L of f of t equals to Laplace transformation of a function f of t is denoted by L of f of t within closed brackets or this kind of brackets you can use, that is equals to, the definition will be Laplace is nothing but finding integration between the limits 0 to infinity. And here inside you will have e power minus, let us take another variable s, that s may be real or complex. E power minus s into that variable which is there in that function, e power minus st into that f of t dt. This is the definition of Laplace transformation of the function f of t. Again I'm explaining, Laplace transformation of the function f of t is denoted by L of f of t. L of f of t equals to, the definition is integral 0 to infinity e power minus, I'm taking a new variable s which is maybe real or complex, e power minus st into f of t dt. And now that is equals to, if you do the integration for this, and if these limits are related to 0 to infinity, limits are related to t, hence if you replace these 0 to infinity limits in the place of t, you will get the answer in terms of s. That means you are going to get another term in terms of s, and that term we are going to take as function. That function we are going to take as this. We are going to represent as capital F, because we are finding Laplace of small f, and the answer of small f is denoting as capital F, and the term will be in terms of s. Therefore here I am denoting that answer which is in terms of s as capital F of s, or small f is there, therefore you can use f bar of s, you can use. Since this term answer, this integration answer will be in terms of s, the term which is in terms of s we are denoting as capital F of s, and the term which we are going to find Laplace we are denoting as small f of t. Okay, and now here if you able to understand these notations are also important, and here I'm using the notation capital F for small f. And now some important formulas we are going to see. L of 1, Laplace transformation of a constant 1 equals to 1 by s. And if you want the proof for this, you can use this formula. That means here what is f of t? 1. L of 1 equals to integral 0 to infinity e power minus st into what is f of t? 1 dt. And now we can prove this. And now how can you prove this? Now that means we are going to find L of 1. L of 1 equals to integral 0 to infinity by using definition. E power minus st into what is f of t? 1 I am going to write into f of t dt. And now that is equals to what is integration? This integration is with respect to t, therefore treat s as constant. That means in the place of s, imagine a. What is e power minus at integration? E power minus at integration is e power minus at. That means e power minus st by that minus st differentiation. Minus st differentiation with respect to t. Therefore minus s is constant into t differentiation is 1. Therefore you will get minus s after completion of the integration. Write the limits 0 to infinity. Which limits are these? T limits. That is equals to apply the limits. And now that is equals to first in the place of t, not s, e power minus s into s is a number which is real or complex. Real number into t place infinity. Real number into infinity. Infinity. Therefore what do we have? E power minus infinity by minus s. In between upper limit and lower limit you will have minus, and here we have 1 minus, minus into minus plus. You will have e power in the place of t again 0, lower limit. 0 into s 0, minus 0 0, e power 0 1 by s we have. And here e power minus infinity is 0. E power minus infinity is 0. Since e power infinity is infinity and e power minus infinity is 1 by e power infinity, 1 by e power infinity means 1 by infinity. 1 by infinity means 1 by constant by 0. Constant by 0 if you take to numerator, 0 by constant into 1. 0 by constant is 0. 0 into 1, 0. E power minus infinity is 0. 0 by minus e power minus infinity is 0. 0 by minus is 0 plus 1 by s. What we have? The answer is 1 by s. Like this we can find L of any function which is in terms of t may be constant. And here like that by using that definition, this definition, we can find the answer which is in terms of s. And here L of 1 equals to 1 by s. L of k, that means here inside Laplace if you have any constant you can take out that. And now here by taking k out, k into L of 1 we have k into L of 1 means 1 by s. K into 1 by s equals to k by s. That means where k is any constant. That means simply if you have any constant in the place of k, that means for example L of 5 equals to what? K by s if you have k, 5 by s if you have 5. If you have 100, L of 100 equals to 100 by s. And now simply few more formulas we have. L of e power at, that is equals to, already as I told before, Laplace we are going to find either constant or the term which is in terms of t. And we are taking the term which is in terms of t as f of t. That means this is f of t. That means in the place of f of t, now we have a e power at. L of e power at. Some standard formulas for standard, for some standard functions we have standard formulas. That means for some standard functions means e power at, e power minus at, sin at, cos at, sin h at, cos h at, t power n. For this kind of functions we have Laplace. And here Laplace of, if you want e power at, the answer is 1 by s minus a. The answer will be in terms of s. And now if you want, and as we did in for previous bit, we can obtain this answer 1 by s minus a by using this formula. That means in the place of f of t, what we have? E power at. By solving this integration we can obtain the answer 1 by s minus a. Similarly L of e power minus at, if we have 1 by s plus a. If we have minus, plus, if we have a, e power, if we have plus, 1 by s minus a. L of sin at, next formula, L of sin at, for sin, a by s square plus a square, this a square, this is the formula. For L of cos at, the formula will be s by, previously a by for sin, s by for cos, s by s square plus a square. For L of sin hyperbolic at, same, if we compare this one to sin at, for sin at in denominator in the place of plus, now we will have minus. That is the only difference. And L of cos hyperbolic at, you will have Same, that is the only difference. In the place of plus we are going to take minus. S by s square minus a square. And now L of t power n, that is equal to, if you want to find L of t square, for example, for that you can obtain the formula using this formula. The formula will be, look at n gamma, and here we have the topic gamma function, gamma n plus 1, gamma n plus 1 by s power n plus 1 is the formula. And here we can look at that gamma definition. If we have the related formula, in the next videos you can discuss. And now particularly we are giving the important case. If n is here, if this formula will be for any n, and particularly if n is positive integer, then the formula will be n factorial by s power n plus 1. That means if n is positive integer, gamma n plus 1 will be equals to n factorial. We can use this formula directly, n factorial by s power n plus 1. That means, for example, if we have L of t square, if we have, where t square means 2 is a positive integer, therefore directly we can use the formula 2 factorial by s power n plus 1, where is n is 2, therefore s cube, 2 factorial by s cube is the formula. And now we have few more formulas. If inside Laplace, if we have e power at into some f of t, that is equals to, for example, if we have L of some e power 3t into, if we have into t square, for example, that means e power at into, let us take this one as f of t. If we have this kind of case, this is related to first shifting property. This is called first shifting property. And here L of e power at into f of t, if we have, the formula will be, answer will be capital F of s minus a. Capital F of s minus a means, already as I explained before, simply here what is meant by capital F of s minus a? In capital F of s, replace s by s minus a. What is capital F of s? This f of t Laplace of this f of t. That means first we have to find this Laplace of this f of t, and already as you know, Laplace of f of t is denoted by capital F of s. Laplace of f of t is denoted by capital F of s. Simply the answer will be, in capital F of s, replace s by s minus a. If we have inside Laplace this kind of e power at into term in terms of t. And now similarly, L into, if f of t is multiplied by some e power minus at, simply same formula. But here in f of t Laplace, which we are going to denote as capital F of s, replace s by this time s plus a. And here notations are important. Must understand what is capital F of s. Capital F of s means Laplace of f of t. In Laplace of f of t, capital F of s, replace s by s plus a. We must understand these formulas. And now here at the same time we have L of, if f of t is multiplied by some t square, t cube, like that. That means if you want L of t into f of t square into f of t, if you want, that is equal to, the formula will be, that is depending upon n. The formula will be minus 1 whole power n d power n by ds power n. With respect to s, we have to do n times differentiation. D power n by ds power n means n times differentiation with respect to s. For which we are going to do this differentiation? For that Laplace of f of t, which we are denoted as capital F of s. Understand this. L of t power n into f of t equals to minus 1 whole power n into d power n by ds power n of capital F of s. And now that is, from this we have this. For example, if n equals to 1, L of, if you want t power 1, that means t into f of t, if you want, the answer of the formula will be minus. That means replace here in the place of n1, minus 1 whole power 1 minus d power 1 by ds power 1 means d by ds of f of s. If you want L of t square into some f of t square into f of t, the formula will be, replace n by 2, minus 1 whole square d square by ds square 2 times differentiation. Here 1 time differentiation if you have t into 2 times differentiation if you have t square, d square by ds square of capital F of s. Again, what is capital F of s? F of t Laplace of this f of t which is there beside t or beside t square. And now one more. Previously we have seen t into t square and f of t. Now we are going to look at by t or by t square. If we have L of f of t by t, some f of t by t, f of t means there, if that is a term in terms of t by t, if we have this kind of form, then the formula is integral s to infinity. That means we have to do the integration between the limits s to infinity. For which term we have to do the integration? Capital F of s. Again, what is capital F of s? This f of t numerator f of t Laplace of this numerator f of t. We have to do the single time integration. And now if we have by t square, the formula will be double integration. Integral s to infinity, and here we have to do 2 times integration. For what? Capital F of s. That means f of t Laplace. For 2 times integration ds we have. And now here one more important formula, L of integrals. If we have inside Laplace integral 0 to t limits, we need to have only the limits 0 to t if we have, and treat this inside term as f of t dt, then the answer will be capital F of s by s. Again, what is capital F of s? Simply inside integral 0 to t, take this term as f of t. Find the Laplace of that f of t. That Laplace of f of t, which is nothing but capital F of s by s. This is the formula. And if you able to understand these formulas, and if you able to read these formulas, and we have few more formulas, and these are the important formulas. And here if you able to understand these formulas, and if you able to read these formulas, then the next formulas, next problems will be easy. You will feel those problems as easy. Okay, thank you.